Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashoud Mamboro. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be focusing on the knowledge area, chemical change. Chemical change is our topic of the day. I would like us as well to start by looking at the diagnostic report with the focus on chemical change. Remember, chemical change, we are talking about your question 5, 6, 7, 8, 9. So we're talking about here question 5, which is usually your rates of reactions, chemical equilibrium, question 6, question 7, your acids and bases, question 8, your galvanic cell, question 9, your electrolytic cell. And then this will be our focus. Remember, this chemical change is 92% of 92 marks out of 150 for paper 2. So I'm hoping that this will definitely help you. We'll be focusing mostly on problem solving. So I hope we'll move together. It's indicated you'll be sitting for your final examination, chemistry paper 2, which is 3 hours. So we are saying here we're going to focus on these 92 marks for today. Now we are hoping that by the end of this lesson you will have understood, you'll be moving together. Now, if you look, everything paper 2 is about periodic table. I would like to emphasize that. And then you will have seen by now the importance of the hydrogen, our number 1 element there, which is hydrogen. And then remember, hydrogen is in group 1, always forming 1 bond because it has 1 electron that it can share with the other elements. Now, the other thing which is important about the periodic table is your group 1 now, you have these metals. Usually we are referring to them as LINAC, which is your lithium, sodium, and potassium. And if you look at these group 1 metals, they have a charge of +1. So meaning that they are most likely to lose 1 electron and have a charge of +1. So this is very much important, more especially when you are dealing with paper 2, where when you look at acids and bases, immediately when you have all these bonded to the OH, we are talking now about the strong bases. The base that are strong is your group 1 elements, so LINAC and the OH. They are able to give us a strong basis. So it's very much important. The same with the hydrogen. If we look here in group 17, we're having your halogens there. And then we are saying if you have hydrogen bonded to the fluorine, hydrogen bonded to the chlorine, hydrogen bonded to the bromine there, then we're getting our acids. What is different between them is the strength. So you will know that in our acids, this one, as long as we have hydrogen bonded to nitrogen, hydrogen bonded to oxygen, hydrogen bonded to fluorine, we know that they have hydrogen bond, which means they have very strong intermolecular forces that are formed between the hydrogen fluoride molecules. So hence this HF, your hydrogen fluoride, will be your weak acid. So this one is your weak acid, which is formed between hydrogen and fluorine, and the other two are strong acids. So you can see that all these what we are doing is based on the periodic table. So that will be our focus. We'll be doing that as well. When you have to calculate the number of moles, you'll definitely use the periodic table to come and look for your molar mass there. So it's very much important that you always, when you are doing your revision, focus on the use or the skills that are based on the use of the periodic table. Now, as well, because here when dealing question 5, 6, 7, 8, and 9, we have a lot of stoichiometric calculations. So it's very much important. We always emphasize the use of your periodic table. The use of your data sheet here to say, now you got to know, if you see mass, you know mass is saying be able to calculate the number of moles. If you see the number of electrons, number of particles, you know you can be able to calculate the number of moles. by dividing the number of particles or number of electrons by Avogadro's number. So always the given information will always direct you as to which formula from the data sheet you must use. The same when you are dealing with your C equals to N over V concentration, as well as this one where you have the mass there and you are looking for concentration, you can use that one. These as well will tell you that at standard conditions, STP, standard temperature and pressure, we are saying that we are able to do that, and we are saying our molar volume is known at STP, which is at 0 degrees Celsius and at a pressure of 180 m or 101.3 kilopascals. So we're saying molar volume there is 22.4 cubic decimeter. And then you are able to calculate the number of moles when you are given the volume under STP. Some of the time, we won't mention the conditions that is under standard conditions. We'll simply give you the molar volume to say the molar volume, for example, at 25 degrees Celsius, can say the molar volume is 25 cubic decimeter. So we're simply saying it doesn't mean that all the time you will be using the molar volume of 22.4. You use the molar volume of 22.4 under standard temperature and pressure, STP there. But as we change the temperature or change the conditions, definitely the molar volume changes. We will give you the value of the molar volume at that particular temperature. So you got to know that that volume can be 22.4 as long as it's under STP, and it can be other values like 24 at 25 degrees. As we change the temperature or as change the conditions, the VM will change as well. And then we are saying all this, you must be able to know that if you are given mass, you can calculate the number of moles, as I've already indicated. If you are given the volume as well at STP, or when molar volume is given, definitely you will use that formula to get the number of moles. As you are given the number of particles, you can be able to divide the number of particles by Avogadro's number to get the number of moles. As you are given the concentration, you can be able to calculate the number of moles as well. So all these are different ways that you must be able to check what am I given. Then you are able to get the number of moles. So remember, the number of moles serves as a bridge that you can be able to know the number of moles of A. If you know the number of moles of A, you will use the mole ratio to get the number of moles of B. Hence, you are able to move to get the unknown one using the known information about A. You are able to get the information about B using a balanced equation. So stoichiometric calculations, they are based on a balanced equation. So I'm hoping that you are well versed with the use of these formulas, and definitely you're going to use them to do your calculations. And then straight to it, remember I said we're doing chemical change. So we're starting with rates of reactions, which you are expecting to be your question 5. So we have different questions that we're going to treat here just to show you the skills of how do you go about answering questions. Remember, in this one, they're saying we have Roll-8 is a tablet which contains calcium carbonate, a very popular calcium carbonate there, our base. A pharmacist wants to determine the rate of reaction. So we're having Roll-8, which is a tablet, and it contains calcium carbonate as an ingredient. And we're saying a pharmacist wants to determine the rate of reaction between stomach acid. You know you have stomach acid. That's where you're finding your hydrochloric acid in your stomach, and Roll-8. I think you have heard people talking about that. The fact that they have a lot of acid that is built in them, and then they are able to buy something. In this case, Roll-8 is the base that we are going to use to neutralize the acid from the stomach. Now he performs an experiment using calcium carbonate, so he's doing it experimentally. He used calcium carbonate, which is powder. Very much important, because you know we have the factors that affect the rate of reactions. And I want to emphasize it here to say, remember, in question 5, our factors that affect the rate of reaction are our dependent variable. That is what we are. It's our independent variable. What we are changing. So always our independent variable, as long as this question is concerned, it will be factors affecting the rates of reactions, which in this case we said is your temperature, it's your concentration, it's your surface area, it's your pressure. Number 5, you are having the catalyst that we have as well, and then we are saying the nature of the reactant. So all of those 6 are the factors that affect the rate of reactions, are our independent variable. So you got to know that the factors are the independent variable and rate of reaction is our dependent variable. You are blessed in question 5, you only have one dependent variable in this case, which is rate of reaction. And then don't have a misconception of thinking that as the time increases, the rate increases. Remember, we are talking about the inverse of time, which is 1 over delta T as your rate of reaction. So as long as the reaction takes lesser time, we have the highest rate. But when the reaction takes longer time, we have the lowest rate. So you got to have that in your mind. So in this experiment, we're having calcium carbonate, which is solid, very much important. Remember, when you have a solid, we can change the surface area of a solid, which in this case, it can be powder, can be lumps, it can be a tablet as you are given there. So you got to know that when you have a solid, we can change its surface area. And we have hydrochloric acid, which is aqueous solution. Remember, for aqueous solution, we're talking about the concentration of aqueous solution. So we have 1 mole of calcium carbonate reacting with 2 moles of hydrochloric acid, which is aqueous, to form a salt, which is calcium chloride, water, and carbon dioxide. So that is our given reaction, and we're going to do questions that are based on that reaction. And if you look there, we always start with the definitions, your level 1 questions that we're expecting you to collect the marks. They're saying define the rate of reaction. Remember, we're saying the rate of reaction is the change in concentration of reactants or products per unit time. So it's the change in concentration of reactants or products per unit time. You're able to get your time. Just for you to remember, it's the change in concentration of reactants. Remember, we have reactants and products per unit time. So you got to always remember the definition. You can write it as a formula, you'll write it in ways, and you'll be able to collect your 2 marks. Now, let's go to the next question that says, what type of reaction takes place between the Rholl-Ace tablet and hydrochloric acid? Remember, we said there was build-up of acid, and then you are drinking the base. What type of reaction do we call that? Remember, we're having an acid reacting with the base. So definitely that must be neutralization. So you will say neutralization, acid-base reaction, and you'll be able to get this type of question. So they're saying, as you deal with that, always remember that the type of reaction is important. In this case, neutralization reaction. Now, the pharmacist repeated the same experiment using the same mass of calcium carbonate, lumps, which factor? Now, when we started, we were using powder. Now they are using lumps. So they are using lumps instead of powder. So the question is saying, which factor? Remember, those are the factors that affect the reaction. So which factor affecting the rate of reaction is the pharmacist investigating? And if you check, we're talking about the calcium carbonate, and we said this is a solid. Sorry for that. This is a solid, so we're talking about mass. So definitely, when we say we're dealing with a solid, we'll talk about surface area. You can call it surface area or state of division. So that will be your answer to say our we are changing, or the factor is surface area or state of division, and then you are able to collect your marks. Now, what is the dependent variable? I just talked about it to say, as long as you are dealing with question 5, you will definitely know that the dependent variable is the rate of reaction, and the independent variables are the factors affecting the rate of reaction. I hope you have that and you won't make a mistake. You'll be able to get that. So they're saying, what is the dependent variable in this reaction? What is the dependent variable for the investigation? And you are saying the dependent variable is the rate of reaction. It's the rate of reaction. So you're able to deal with that and you collect your marks. And then as we continue with the question, Now they are saying in the second experiment, 53 cubic centimeter of carbon dioxide, so of the product of carbon dioxide, was produced in 1 minute. Calculate the average rate of reaction in moles per second. So that is your moles per second. I always say to learners, as far as this one is concerned, the SI unit, mole per second, already is telling you which formula to use, which in this case will be change in number of moles over change in time. So you're able to see that as long as we are dealing with the SI unit of mole per second, will be change in number of moles per unit time. However, I want to always conscientize you to say if we are dealing with something like calcium carbonate, which has mass, the rate of reaction will be change in mass per unit time. If you are dealing with hydrochloric acid, which is an aqueous solution, the rate of reaction will be change in concentration per unit time. And the same if we are dealing with calcium chloride, which will be change in concentration per unit time because it's aqueous solution. And when we are dealing with carbon dioxide, definitely it will be change in volume per unit time. In this case, they said in moles per second. The answer must be in moles per second. So definitely that moles per second is telling you something to say we are not going to answer this question in, remember the SI unit for change in volume per unit time. The change in volume per unit time, it will definitely be cubic decimeter. Let me write it here. Change in volume per unit time, the SI unit will be cubic decimeter per second. So in this case, they didn't say you must use change in volume, change in V per delta T. They said you must use you must use moles per second. So you got to have that understanding to say the first thing you need is the number of moles in order for you to calculate. But all these are different ways which you can calculate the rate of reaction. In this case, they said in changing number of moles per unit time in moles per second. So that's how we're going to do our calculations. And what is important is that this reaction is at standard conditions. Then immediately when you have that, you are able to see that if I'm given 53 cubic centimeter, I can be able to calculate the number of moles using that formula N equals to V over Vm. The importance of that. The molar volume at STP definitely is 22,4. You must be careful when you are dealing with this type of questions because you are given cubic decimeter and the molar volume we said is 22,4 cubic decimeter. So definitely you got to do conversions here. You got to do conversions either of the cubic centimeter or of the cubic decimeter, which is your molar volume. So very, very much important when you're doing your calculations. If you want to stay with 53, you will say 53, but this volume as well must be in cubic decimeter, so that you are able cubic decimeter per mole, so that you are able to get the correct answer. So hence you are saying now, if you say 53, then you will multiply this by 1,000 so that it becomes cubic decimeter per mole, and then you are able to say 53 over 22,400 cubic centimeters. Then you can be able to get your number of moles. And this is how the question was worked out. To say the first thing, you are saying I'm having the formula number of moles of carbon dioxide because we have the volume of carbon dioxide. You divide it by the molar volume, but the units must be the same. So I'm saying you have two options. You can divide 53 by 1,000 or you can multiply 22,4 by 1,000. In this case, we multiply 22,4 by 1,000 to convert it to cubic centimeter per mole. Then we are able now to get number of moles of carbon dioxide as 0,002366 mole. And then after that, we can be able to use the mole ratio as well to calculate the number of moles of HCl. In this case, number of moles of HCl is the ratio is 1:2, so you can multiply that by 2, and then you are able to go to our formula, which is change in number of moles over change in time, which in this case was 0.004732 divide. Don't forget to convert minutes to second, because the SI unit given there was in moles per second. However, in the exam, you can find a question that say calculating moles per minute. So if we're saying mole per minute, you will divide by 1. But in this case, they said mole per second. So meaning that the 1 minute must be converted to second. Hence, we are dividing by 60, and you can see the rate at which HCl is being used up there is 0.0000789, or 7.89 times 10 to the power of minus 5 moles per second, and then you are able to get your answer there. So I hope that helps you as you continue to practice this type of questions. And then without wasting time, we go to the question on chemical equilibrium. Chemical equilibrium, I think this is one of the most famous questions because of KC calculations. And I always say, KC, you just need to have skills of doing the problem, because learners tend to spend even more time doing KC that they don't even do other questions which are even much easier and where they can even get even more marks. So I'm saying here what matters is the skills of how we're going to mark these particular questions, and I will be explaining to yourself to say how do you go about dealing with this question. Remember chemical equilibrium, question 6. In this case, they are saying nitrosyl bromide decomposes to form nitric oxide and bromine gas, Br2 gas, according to the balanced equation below. So we're given the balanced equation. And then, as indicated, they are saying now initially we had 55 grams. I know you don't want to see mass. When you see mass, you see number of moles. So definitely you know that you are going to have to calculate the number of moles of nitrosyl bromide, because you are given mass of nitrosyl bromide as 55 grams. So, and you know that to calculate the number of moles, you will need to use N equals to mass over molar mass. So you will need that. You will need to use N equals to mass over molar mass. So very much important. Already you are given the mass. You just have to find the molar mass of nitrosyl bromide, which now you will definitely use your periodic table to look for the molar mass there. And then immediately you get the molar mass, you are able to do the calculation of number of moles of nitrosyl bromide. So it means as long as you are given the mass of a substance and the the formula mass as well, you know already that you will be able to determine the number of moles. And when you get number of moles, you are able to move with number of moles to other things. Now, the next important thing is that we are given is sealed in a 2 liter or 2 cubic centimeter container. Very much important. Remember, equilibrium, we can only reach equilibrium if the reaction is reversible, and we can only reach equilibrium if the reaction is taking place in a closed system. So definitely they are saying the container is closed and then the reaction is reversible. So those are the two conditions for us to reach chemical equilibrium. Remember, it's very much important for you to have that in mind. To say, okay, the reaction must be reversible and it must be in a closed system for us to reach equilibrium. So they are saying the volume of this container is 2 cubic centimeter. And they are saying this nitrosyl bromide is allowed to decompose. So it's decomposing, is changing. There is change from 55 grams of nitrosyl bromide. And at equilibrium, when we reach equilibrium, 78% of the nitrosyl bromide has decomposed. So now there is a change in terms of nitrosyl bromide. Remember, we started with 55 grams, which we are going to calculate the number of moles of nitrosyl bromide. And then when we get the number of moles, we are going to say, okay, this is what we are starting with. We are starting with the number of moles, which is 55 over the molar mass of nitrosyl bromide. And immediately when you do that, you are going to get 78% of this number of moles that we are starting with. You are going to multiply 78 over 100 to the initial number of moles to get what is the change. What is the change in the number of moles? But remember, we are always, almost always advising you to use the RICE table there to say, let's always start by focusing on the ratio, which in this case is 2 is to 2 is to 1. So that is your RICE. Your first R is for ratio, and then the I is for the initial number of moles. In this case, we are given initial number of moles of nitrosyl bromide. Remember, when the reaction starts, we only have nitrosyl bromide. We don't have products. Hence, initially, definitely you're going to have a 0 of nitric oxide and 0 of bromine gas. When you start the reaction, you only have this nitrosyl bromide. So definitely, when you have that, that is your initial. Then you must be able to move to the change. And already they are telling you that there is change that happens. Is that 78% of NOBr is decomposed. Is decomposed. It has been used to form something. So you are finding the change, which is 78% of the initial that we started with. And then you will be able to subtract what you started with the decomposed one. You get now the equilibrium number of moles. And it's only when you have equilibrium number of moles where you can be able to divide by volume in order for you to get the concentration at equilibrium. So our concentration is always at equilibrium. And look at this question. It has 8 marks. So I want to emphasize the skills in how to go about collecting marks in this question. Now look at the marking criteria there. Our marking criteria is saying, first thing, you will get 1 mark for getting initial moles of NBr. So you're going to get divide the 55 by the molar mass of NOBr. I hope you have been calculating it, and if you did it correctly, you got your 110 for that nitrosyl bromide. And then immediately when you say number of moles is mass over molar mass, you are going to get that 1 mark of finding the initial number of moles. Immediately, the initial number of moles, when you take initial number of moles and you multiply that by 78 over 100, 78%, you are going to get how much was used or how much decomposed of the nitrosyl bromide, and that will give you another mark. You see now, just to use the correct ratio, this is very much important. Immediately when you have one change, you use that change to get other changes. So the most important part of solving this problem is to get one change, because all the changes are according to the ratio. So you're going to say, okay, if the change in NOBr is 0.39, the change in nitric oxide will be 0.39. Why? Because they have the same mole ratio. Is 2 is to 2. So it means the change must be the same. 0.39 for nitrosyl bromide, 0.39 for nitric oxide. And then you are going to say, okay, for the ratio for bromine gas is 1 mole. So 1 mole means the 0.39. We're going to divide it by 2 in order for us to get the number of moles of bromine, and then the change, you got all the changes. So all the changes are according to this one. And we are saying for us to award this mark is for you to be able to show us that the ratio is 2x is to 2x is to 1x. And then x, we were able now to find what is happening in terms of x, and then you are able to get your answer there. So your 2x in this case is 0.39, which is what, according to this, you will see when you do the calculations. Definitely this one must be half of the 2x, and then you are able to get the mark for the ratio. So that mark of the ratio is always there, and we're expecting that all the time you will collect the mark of the ratio. Now calculate the moles at equilibrium. You must be able to calculate. Remember, on the reactants, you're going to have your initial, you're going to have your change. Then you're saying we started maybe with 0.5. What was the change? In this case, you said 0.39. You got to be able to say what is at equilibrium, what is remaining at equilibrium. If we started with 0.5, and then that 0.5, 0.39 was decomposed, how much is left, and then you are able to get the number of moles at equilibrium. Another free mark is for you to always divide by volume. Definitely, you're going to divide by volume and get that mark. So you cannot miss the mark of the ratio. You cannot miss the mark of dividing the equilibrium concentration. You always divide number of moles at equilibrium, you divide by volume, given volume. You will definitely get that one mark. Now, the other mark is for correct Kc expression. I want to explain this one. To say, when we say correct Kc expression, you are not saying Kc equals to concentration of product over concentration of reactants. This is not the correct Kc expression. This is what we use to ensure that you understand how we get the Kc expression. So what we are expecting of you is to write the correct Kc expression according to the given equation there. So this one is not what we are going to mark for you as a Kc. It's not a Kc expression. The Kc expression for this particular question will be Kc equals to concentration of NO, which is a product. Remember, the coefficient not inside but on top. You cannot put powder milk in the fridge. You can put it on top of the fridge. Please, you just put the 2 on top, not inside the coefficient, not inside but on top. And then you have your bromine gas Br2. You write it like that. Remember, you can't take this Br2 is written as Br2. It's a subscript. You can't take these two and put it as a power there in terms of like this coefficient. It's only for coefficients that we put on top, not inside but on top. But the Br2 like that, you'll write as it is, because if you check Br2, we are simply saying it's a Br bonded to Br. There is not necessarily a 2 there. It's just a Br bonded to another Br. Hence, we just write it as Br2 for simplicity. And hence, we are saying there's no 2 here to put. We have a 1 here. So it's only the coefficients that we put as the powers there, as a power of. So this is a power of 1. So you'll say this is the concentration of NO to the power of 2, Br2, concentration of Br2 to the power of 1. You don't have to write the 1. And the concentration of nitrosyl bromide, NOBr, to the power of 2. Please don't forget, because immediately when you don't write those 2's that are the coefficients there on top of those concentrations, you will definitely lose the mark. And this is the one mark that you are saying you must have it. Now, it's very much important here to say, if you write incorrect Kc expression, it means your marks will end up here. You will get 5/8 because your Kc expression is incorrect. But if you don't write Kc expression, but you substitute the values correctly and get the correct answer, which in this case is supposed to be 1,23, you will get 7/8. So ensure that you write the correct Kc expression, because if your Kc expression is wrong, we'll stop marking at the Kc expression, then you won't get all the marks. But if you write if the Kc expression is not there, but you're able to do everything else correct, you will get 7/8. I think I've guided you there. You see that always ensure that you write Kc expression, but you write correct Kc expression. And I say this one, you can write in your rough work, the Kc equals to concentration of products over concentration of reactants. But in your book, we're expecting to see the correct Kc expression, and then you will come and substitute, and then you will get a correct answer. Then you will be able to come back with your 8 marks. So it's very much important. Now let's go to the solution itself. I've shown you the marking criteria, how the marks will be allocated in terms of chemical or Kc calculations. Now let's look at what I've explained already. Remember, we're given 55 grams, and when you see grams, you see number of moles. So we say 55 over molar mass of nitrosyl bromide, which is 110. That's how we got the first mark, which we're referring to as A in our marking criteria there. To say, okay, the first mark is for dividing 55 grams with 110, or for determining the number of moles because we were given mass. The second mark is for getting the number of moles decomposed. Number of moles decomposed. Remember, initially we have 0.5. Of this 0.5, 0.78 decomposed or was used. So what are we left? So you're just taking 0.5, you multiply it by 78%, which is 78 over 100. And then that's where you will get your second mark. So I hope we are together. And all you need is one change. Once you got one change, you are able to get all the changes that you want. So what am I saying? I'm saying initially when we started, we only had nitrosyl bromide, which was 0.5 moles. And we didn't have product because the reaction was just starting. It was 0.0, our product. So we were able to get the first mark there for that one. Now, the second step, you said 78% was used or decomposed. So you multiply 78% by to the initial to get the change in moles of nitrosyl bromide. And then you got 0.39, which is your second mark. The third mark is for the ratio of all of them. Remember I said the ratio is on the change. When you're dealing with change, that's why you'll be focusing on the ratio. And our ratio here is that 2:2, which means 0.39 is the same here. It will be 0.39 because the mole ratio is the same. Now, as when you come to bromine gas, we are saying for bromine gas is half because it's 1 of that. What is half of 0.39? You just say 0.39 divided by 2, and definitely you'll get 0.195. And this mark is for all the ratios, not only for 0.195. So this mark is for all the ratios. I want us to be together on that one. Now, the next mark is that you are going to say on the reactant side, we started with 0.5. We used 0.39. At equilibrium, we're left with 0.11. In terms of nitrogen oxide, we started with 0. Because of the ratio, we said is 2:2. So the change is the same here. So it will be 0.39. And then if you say 0.39 plus 0.0 plus 0.39, you get this one. So you can see on the reactants, because they were being used up, we subtracted initial minus change, we got equilibrium. When it comes to the product side, we started with 0, we added because products are being formed. So it's plus 0.39, we got 0.39, 0 and 0.195, we got 0.195. So for subtraction on the reactant side and for addition on the product side, we're giving you another mark. Remember, you have 4 marks already. The mark, because you have moles at equilibrium now for all the 3, you are now going to divide by the volume to get the concentration at equilibrium. So the only concentration that we use on the Kc expression is the concentration at equilibrium, which in this case, you're going to take 0.11, you divide it by 2. 0.39, you divide it by 2. 0.195, you divide it by 2. And then for dividing by that 2, you will get another mark. You see, on the table already, you are having 5 marks. So please always remind yourself that there will always be a mark for the ratio. In this case, you said it's 2x, 2x, 1x. You'll get 1 mark for that. And then there will always be a mark for dividing by volume. As long as the concentration is not given, you will definitely have to divide by volume to get the concentration at equilibrium. So always have those marks that you can simply collect. The mark of subtracting on the reactant side, the mark of adding on the product side. And then learners, most of the time, they ask this question to say, is it possible that we can find ourselves subtracting on the product side and adding on the reactant? Remember, this equilibrium that we're having, it can be disturbed. When you disturb, maybe the change is done on the product side. It means the reaction now is starting from the product side to the reactant side. Definitely, when you're doing your change, you're going to subtract. So I want you to have that because we have seen question papers that goes like that. So after you've done with your table, you have 5 marks. You are left with the mark of writing the Kc expression, the mark of substitution, and the mark, final mark. And then you're able to write Kc expression, 1 mark, and then substitution, correct substitution of these values. Let's say you have made a mistake. You've calculated the concentration but your concentration was not consistent. But at the end of the day, substitute your concentration, because it's your concentration that you are substituting. Then we're able to look at that and then write your final answer. So all these steps must be there in your KC calculation. Don't leave this question without answering it, because there are marks that you will definitely collect. So I hope this helped you. But let's look at other questions based on chemical equilibrium. Now, Le Chatelain's principle. So it's important that you are able to state Le Chatelain's principle. State Le Chatelain's principle, and then we are saying in this case, when the equilibrium in a closed system is disturbed, equilibrium in a closed system is disturbed, the system will restate a new equilibrium by doing what? By favoring the reaction that will oppose the disturbance. Under chemical equilibrium, we don't have many definitions, hence we are expecting you that you will know how to define chemical equilibrium, which we said is a dynamic equilibrium where the rate of forward reaction is equal to the rate of reverse reaction. And then you must be able to state Le Chatelain's principle. In this case, we are saying when the equilibrium in a closed system is disturbed, the reaction will restate a new equilibrium by favoring the reaction that will oppose the disturbance. Please know Le Chatelain's principle, know how to define chemical equilibrium. Remember, when it comes to factors, for the rates of reactions, we said there are 6 factors. But for chemical equilibrium, we're saying there are 3 factors. I know majority of you want to say Cape Town, which is your CPT, so that you remember that chemical equilibrium can only be affected by concentration, pressure, and temperature. And now let's look at other questions that are based on this one. Now they're saying the reaction. Remember, when we started, we said the volume of the reaction vessel is now changed from 2. It was 2 cubic decimeter. Remember, we're dividing it when we're calculating Kc. They are saying that volume now is now changed or decreased to 1 cubic decimeter, and the temperature was remained the same. Very much important, the statement, the temperature remains the same, or the temperature was kept the same. Now, how will the following be affected? The instruction is very clear. You can only write increase, decrease, or remain the same. Just follow instructions. If the question says write only increase, decrease, or remain the same, just do that. Just write increase, decrease, or remain the same. So they are saying now, how will the following be affected? How will the Kc value be affected? Remember, what is the change? You got to see the change. The volume was 2, it became 1. It means the volume was decreased. Now you got to ask yourself, does volume one of the factors that affect chemical equilibrium? Is this equilibrium going to be affected by volume? That is the first question you ask yourself. You say, okay, volume. We didn't talk about volume. We said Cape Town. We said concentration, pressure, and temperature. But remember, the decrease in volume definitely means increase in pressure. So don't forget that as far as question 6 is concerned. And don't be confused when you are in question 5, because the meaning changes depending on the question. When you're in question 6, we are saying now, if we are talking about the volume of the container, it's different when you talk about the volume of the content. Here we're talking about the volume of the container, to say when the volume of the container decreases from 2 cubic centimeter to 1 cubic centimeter, you are decreasing volume. It means you are increasing pressure. So it means when you increase pressure, the factor that is being changed there is increase in pressure. That's what I want you to see. Now, Kc, ask yourself, how many factors affect Kc? Remember, for rates of fractions, we said it's 6 factors. For chemical equilibrium, we said it's 3 factors that affect chemical equilibrium, which is your concentration, pressure, and temperature. But when it comes to Kc, Kc can only be affected by temperature. There is only one factor. Hence, I say the formation here is 6 factors for rates, 3 for chemical equilibrium, and 1 for Kc. So it's 6, 3, 1. Those who know what I'm talking about in terms of soccer. Now, the Kc value, we are saying now is only one factor, which is temperature in this case. Did we change temperature? Temperature was kept constant. You see how tricky this question is. The main issue, keyword there, that the temperature was not changed, and Kc can only be changed by change in temperature. Hence, we are saying Kc value will remain the same. Kc value will remain the same because increase in pressure does not affect Kc. Kc is only affected by temperature. Let's go to the next question, which says the number of moles of bromine gas formed at the new equilibrium. You see now, we no longer talk about Kc, we're talking about equilibrium. Talking about equilibrium, does increasing pressure disturb equilibrium? Yes, it's a fact. Pressure is a fact. So you got to know that when you increase pressure, it favors the least number of moles. When you decrease pressure, it favors the highest number of moles. So you got to go back to the reaction and say between the forward direction, I must talk the correct language, the forward direction and the reverse direction, which one has highest or less number of moles? Let's check. Here we have two molecules of nitrous bromide, which is two molecules here. And then when it comes to nitric acid, this side we have 2 + 1, which is 3 moles. So we have 3 molecules compared to 2 molecules on the reverse reaction there. So you know, increasing pressure favors the reverse reaction. Increasing pressure favors the lowest or the least number of moles, and least number of moles is on the reverse. So you can see these are now factors affecting the rate of reaction. To say, okay, as we decrease volume, we're increasing pressure, and when we increase pressure, it favors the least number of moles. Which one is least number of moles? Reverse reaction. Hence, the reverse reaction will be favored. And if the question was what will happen to the concentration of NOBr, you will definitely say it will increase because the reverse reaction is favored. So I hope I've explained to you nicely to say the bromine gas in the product will decrease. Definitely they will ask you a question to say how come. Use Le principle to fully explain your answer for question 6.3.2. Definitely when you increase your pressure, we are saying that equilibrium will be disturbed, because when you decrease volume, you are increasing pressure, and increasing pressure will favor the least number of moles, which is the reverse reaction. So you can see where your 3 marks comes from. And then with no problem, you are able to say the decrease in volume will increase pressure, 1 mark. According to Le principle, the system will try to decrease pressure by favoring the direction that produces less moles. That's what I'm saying, to say increasing pressure favors the least number of moles. That is your second bullet. The last bullet is to say the reverse reaction is favored. And then you go to 3 marks there, you are 3 marks richer, and the question was 15 marks. I hope you will do many questions like this one and be able to move forward and be able to write and pass. Now, with no waste of time, we go to acids and bases. Acids and bases. I want you to learn. Remember, in acids and bases, we're having a lot of definitions there. Please have some time in the afternoon, at night, study those definitions, because you definitely don't know which one will be asked in your exam. But if you know, there are simple definitions that you can always remember. So I'm saying, please spend some time doing these definitions. Ammonia or NH3 reacts with hydrochloric acid, HCl, to form a salt. So you know, we're having a reaction of a base, which is ammonia in this case, and your HCl, which is an acid, to form a salt. As shown in that reaction, identify the base in the above equation. Remember, these are common acids and bases. You got to know the common acids and bases. I think I would like to remind you that, remember, when it comes to common acids, we are talking about your hydrochloric acid, your nitric acid, and your sulfuric acid. So you know that those are common acids. These ones, you got to know them. Hydrochloric acid, nitric acid, and sulfuric acid, you got to know them. So they are saying which one, definitely you know HCl is your hydrochloric acid, and then you are able to remember that this one is an acid, definitely ammonia is a base. So you're able to say NH3 is your base or ammonia is your base. And then give a reason for your answer in question 7.1. I always emphasize this to learners to say in paper 2, when I say give a reason, mostly we're saying define. Define. We're saying by definition, what makes ammonia to be a base in this reaction? And if you can check, ammonia is accepting a proton. It's a proton acceptor. And that's the definition according to Lori Bronsted of your base. It's a proton acceptor or a hydrogen ion acceptor. So definitely you will say ammonia is a base because it's a proton or a hydrogen ion acceptor. So you are able to get that mark and use any of that. Even you just say it's an H plus acceptor, definitely will give you your mark. Now, write down the name of the salt formed. So that's me saying, write down this name, and then you know you have ammonia and hydrogen chloride. So obviously now it will be ammonium chloride. Ammonium chloride as the name of the salt that is formed. So you can see, and I like how these questions are structured because they are taking you through the journey of this topic. And then from the definition to say the first thing that you must know is a definition. And the definition is either according to Lori Bronsted or Arenas model. So you got to know that when it comes to Arenas, you are saying an acid. An acid is a substance that produces hydrogen ion in aqueous solution, and a base produces hydroxide ion in aqueous solution. And then when we go to Lori Bronsted, acid is a proton donor, base is a proton acceptor. Please always, and we are talking here about acid, the reaction between acid and the base. Now, they say NH3 plus HCl forming ammonium chloride. They are saying NH4Cl, this salt that is formed here, can undergo hydrolysis. Hydrolysis. So you got to know how to define the term hydrolysis. Remember, this is a salt. So now definitely hydrolysis is a reaction of salt and water. I like to the direction of salt with the water. I like to remind you that we talked as well when you're dealing with organic molecules. You have talked about hydrolysis when you're doing substitution there, where you used water and mild heat, and you use dilute sodium hydroxide and mild heat. We said that reaction when you're having a halogen, a haloalkane, and then you bring those conditions. We said the reaction is hydrolysis that forms an alcohol in terms of organic molecules. In this case, we are saying now hydrolysis now is a reaction of salt with water. When you add water to a salt, you are able to know that this is a reaction of salt with water is referred to as hydrolysis. Now, the next question says, write down a balanced equation for the hydrolysis of ammonium chloride. When we started, I took you through the periodic table. I want to emphasize this to say, as long as you are having lithium, sodium, and potassium in a salt, you know these ones, they are likely going to form positive charges. And when you're having the group 17 elements, the nonmetals there, which are most likely, you are talking about your fluorine ion, it will be -1, your chlorine ion, your bromine ion, just like that. Those ones group. And your iodine, all of these, they will form a minus. So when you are having a salt like this, you got to know that when we separate the chlorine, it will form chlorine minus. That must come in natural to you, and I want you to practice that, because before you do hydrolysis, it's easy when you first separate or split the salt. How do you split? You'll split. If you have a nonmetal like your bromine there, you will split it, you'll take it out. It's okay. What am I going to have here? I will have NH4 plus and chlorine minus. But if, for example, just to expand your understanding, if we had the salt that is called sodium CH3, say CH3COO, sodium, sodium acetate, something like that. If we have such a salt, when you separate it, definitely you know that you're going to have a sodium plus and the ethanoate there, which is your CH3COO minus. So you are able to see that, okay, if I have the sodiums, they will take a plus. If I have the chlorines, they will take a minus. So that immediately when you have that, I'm telling you this section, it will be easier for you. So you see that the chlorine will be minus because a salt, it has a positive, it forms the cation and the anion, the positive charge and the negative charge. Immediately when you put salt in water, it ionizes and it forms ions, which is one of the definitions that you have when you defined an electrolyte. So have that in your mind as well. So in this case, we're having NH4 plus and chlorine minus. Then look as to where are these coming from. HCl, where are you coming from? I mean, Cl minus, where do you come from? We know that this comes from HCl, hydrochloric acid, which is a strong acid. And we are saying these ions of strong acids do not undergo hydrolysis. So no hydrolysis for ions of strong acids and ions of strong bases. So once you have that, I'm telling you we're gone. Because hydrolysis, it simply means you're going to take NH4 plus, you add it into water. And because it has plus, it means it has plenty of H pluses. It has plenty. There's extra H plus. Definitely it must give it away. So if it's a plus, it will give. If it's a minus, it's in need of the H plus. So in this case, we're having NH4 plus, which definitely will donate or will give H plus to the H2O there. So you see the type of answer you'll have in this case. To say, okay, we must be able to take H plus here and give it to H2O in order for this one to be our ammonia. So when you look at how to do it, and then if you practice this, which I'm talking about, you will definitely do well. So the question was, write down a balanced equation for the hydrolysis of ammonium chloride and indicate whether the solution will be acidic, alkaline, or neutral. The question can be changed to say, indicate whether the pH will be less than 7, the pH will be more than 7, or the pH will be 7. So you're able, the same question can be asked using pH. So you got to know that here they're saying acidic, alkaline, neutral, but in your head, you know when you say acidic, you're saying the pH less than 7. When you say alkaline, you're saying the pH of 7, and when you say neutral, you're saying the pH of about 7. So you are able to see that. Now, let's take our NH4 plus, and then we take our NH4 plus in water. Definitely, because it has H plus, it will give and then form H3O plus NH3. And because always when we form H3O plus here, the solution is acidic because it forms H3O plus. But you can even change it and say, okay, this NH4 was from ammonia, NH4, NH3, the reaction was from NH3 and HCl, which in this case is a weak base and a strong acid. So a salt of strong acid and weak base will be acidic. So this will be acidic. Why? Because it forms H3O plus. Or it's acidic because it's a salt of a weak base and strong acid. Then you got your 3 marks. You are richer. That is 1%. Remember, 1% is what you will see in your statement end of the year for physical sciences. So if you are knowing this hydrolysis, you know that it can add a percentage to the marks that you will get. So take it as serious as I'm taking it here. Now let's go to our reaction there. You can see we're having our titration apparatus. We are always indicating to yourselves. So know these apparatus, know them. They must be in you. You got to always know these apparatus to say what we call apparatus A, what do you call apparatus B, and then what is that apparator, and then even the rotate stand there to say we're using a rotate stand, we're having a beaker for titration. Know this because definitely these are exam questions. Let's look at our questions here. They are saying the diagram below shows the titration of 25 ml of sulfuric acid, and you know, Musa, I said SA. I said the acids which are strong. I said you have your H, you have your hydrochloric acid, your nitric acid, and your sulfuric acid. So you know sulfuric acid is a strong acid. Now they're saying we have 25 mils of sulfuric acid and then of unknown concentration. So unknown concentration with, we're titrating 25 mils of sulfuric acid, we don't know the concentration, with 0.2 moles per cubic decimeter of sodium hydroxide. So this one is the concentration is known. So when the concentration is known, we call it standard solution. What is a standard solution? It's a solution of known concentration. So you are able to get that. And the balance equation is given as like that. And then look at the mole ratios there. You have H2SO4 reacting 2 moles of sulfuric acid to form sodium sulfate and then plus water there. Now identify apparatus A. So the question is, say, what is A? And then I can see you smiling, saying this is definitely a burette. It's a burette. Remember, that is a burette. That is a conical flask. You've got to always know what to use for titration. Bromothymol blue was used as an indicator. Now they are saying in this, we are having bromothymol blue, and then write down the color change. You see now, the importance of science, you go to check. What are we reacting? We are reacting a strong acid with a strong base. So you got to know that when we have strong and strong, we'll get neutral. So I always say, when we have a strong acid and a weak base, we did that. So when we're talking about ammonium chloride, the solution will be acidic. But when we have a strong acid and a strong base, the solution will be neutral. But when we have a weak acid and a strong base, the solution will be alkaline or basic. Let me put it that way. And you got to know that when it comes to indicator choice, we are saying MPP. So you know that is methyl orange, bromothymol blue, phenolphthalein. And for this one, you'll see that it's bromothymol blue. Did they say that? Yes, it's bromothymol blue. Now the question is, what is the color change? And for color change, you are saying Roy B cap. So which is your Roy RO, Roy B cap. And we are here, we're using bromothymol blue. What would be the color change? Yellow to blue. So you got to always remember this, which I'm showing you that, and then you'll be able to get these questions easily. As we say, choose between blue to yellow or yellow to blue. So you can see is yellow to blue, and you are able to answer that question. And then without wasting time, let me move. And then we are having we have a graph there. During this titration, the pH of solution was measured as the volume of the base increased. The following graph was produced. What a nice graph. Give the name of the position labeled 3. The name of the position labeled 3. They're talking about this position on the graph. Is it equivalence point or end point? So you got to first ask yourself, what is an end point? What is equivalent point? I usually say end point is like a destiny, and then equivalence point is what? It's like it's like the event that is happening where you are going. So the end point is a point. Remember, this is the only time when you are allowed to say the point is a point. Remember when you talk about melting point and boiling point, we said melting point is a temperature, not a point. It's a temperature. Melting point is the temperature at which the solid phase and the liquid phase are at equilibrium. And then we said the boiling point is a temperature at which the vapor pressure is equal to the atmospheric pressure. It's important because now you are revising. When you see a point, it must remind you of other points. But this equivalence point is a point where all the acid has completely reacted with the base. And the end point is the point when the indicator changes color. It means when you arrive at the end point, the indicator will change color and we have reached the end point. And at the end point, we have what is called the equivalence point. Remember, we talked about a strong acid and a weak base. So a strong acid and a weak base, we're saying the equivalence point will be on the acidic. The pH will be less than 7 for the acidic. Neutral, it will be 7. and then basic, it will be more than 7. So if you look at point 3 there, you can see that the pH is at 7. So you are able to say, okay, we have reached the equivalence point. And our equivalence point, which is the point where all the acid has completely reacted with the base, is at 3 there. And then you are able to see that this is equivalence point. It's not endpoint, it's the equivalence point. So I think I have done a good justice to explain that. The question continues. Use the graph and the information provided earlier to calculate. So it's very much important to calculate the original. Hey, this one is a nice question. The original. You see, you must always underline the keywords. Is the original concentration. Use the graph and the information provided. What was the information provided? You see, data collection. Remember, you had the concentration. I said it's a standard concentration of 0.2. You had the 25 mils of your acid there. All that information, I'm just bringing it back so that you always do data collection to say we had 25 mils of sulfuric acid, which was unknown, with a standard solution, which is 0.2 moles per cubic decimeter of sodium hydroxide. So you can see here, we're talking about now titration. It's a titration curve. You can see there, we are starting at 0 there, which means the volume is before we add. So it means here, at the first point where the graph is starting, we only have the acid. And you can see our acid as a pH of less than 2. And then as we continue to titrate, you can see that the pH is increasing. And at equivalence point, there we said at that point is when the pH is around 7, and said we've reached the equivalence point, which means all the acid has completely reacted with the acid. So you can see this is a titration. So we're talking about titration here, and you know for titration, Kavana, the CAVA formula. Kavana formula, I find it very useful in terms of this one. It makes life much easier. However, there's still learners who prefers to use C equals to N over V. You are allowed to use either C equals to N over V or the CAVA over CBVB equals to NA over NB. So you can use any of those as I move. Then if you are using any of those, you'll get 1 mark for the that is the criteria. You'll get 1 mark for the formula. You'll get 1 mark for the correct substitution, and then you'll get 1 mark for the ratio of moles used, and you'll get 1 mark for the substitution or the substitution of 25, which is for the AVA. Final answer, you'll get 1 mark. So you have 5 marks there for you. So you can choose any method that you want to use to be able to answer this question, and without any wasting of time, you are able to do the calculation in one of those ways. So if you use the CAVA over CBVB equals to NA over NB, definitely you are substituting. You don't have to convert because they are all in milliliters. So you just write 25, 20 there. For the acid is 25. For the base, it was 20. The concentration was 0.2. And then you write the mole ratio from the balanced equation. Remember, one mole of sulfuric acid is reacting with 2 moles of sodium hydroxide. Hence, we are writing 1 over 2. There's a mark for the ratio. There's a mark for the 2 substitution. Just look at the number of marks you're collecting. So please ensure that you do this type of questions. And where did we get this volume of a base? Because it was not given. It's given there. The volume of the base that was used is given on the titration curve there. You are able to see that we got that volume. And then you are able to say, okay, the concentration of the acid is 0.08 moles per cubic decimeter. You can use the C equals to N over V. Start with what you have to get what you want. So you can do that and say, okay, we're given the concentration of 0.2 sodium hydroxide, our standard solution. We're given 20, and then the 20 you always convert. When you're using C equals N over V, you divide there by 1,000, you get 0.02, and then you get the number of moles of sodium hydroxide, which is 2 moles. And you know, for every 2 moles, we have 1 mole of the acid. Definitely, you will divide the 0.04 by 2, you get 0.02. So that mark of the mole ratio, you get it. And then you go and calculate the number of moles, which is C equals to N over V. Everything must be in cubic in the correct SI unit. Number of moles, the volume 25 mils. You must divide it by 1,000 to get cubic decimeter. And then you get the same answer. So whichever method you choose to use there, you are allowed, and it will definitely work for you. Now, without wasting time, we go to the last two questions that are based on the topic called electrochemistry. And I always find it more fascinating that when you know the table of standard reduction potential, I think it will always help you. And if you check, you will see that there is an arrow that goes on the left on table 4b that goes downwards, and there is an arrow on table 4b again that goes up. And on the left, you are saying we're having oxidizing agent. And as we move down, there is increasing ability, oxidizing ability. So the strength of oxidizing agents increases as we go down the table, as we go up this side on the right hand side. So on the right, we are going to have oxidizing agent. What they do, they gain electrons, they undergo reduction, and we call them oxidizing agent. They are reduced. So once you write that there, it will always remind you what is happening on the left hand side of the table. And on the right, we are having loss of electron, which is oxidation, and that's where we find our reducing agent. And our reducing agent is oxidized. Remember, we always move from A to C, A and C, from A to C, from anode to cathode. So you will still find your anode there at the top, your cathode there. So once you have done that, in terms of galvanic cells, you are set. You are set. You know that any question comes, you are ready to answer. You will see we're going to do questions. We'll come back to this table, and it's going to assist us to answer the questions. Now, a galvanic cell is set up under standard conditions as represented by the cell notation below. So now, the most important thing here for you to understand is that the question, you can be given the two beakers with your electrodes, your conducting wires, your salt bridge, all that. But you can be given cell notation like this one, and then the questions can be asked. You can be given the net ionic cell reaction, and then still from there you can. So you got to know that the question won't always have two beakers and then obvious stuff. Sometimes we'll just give you a cell notation like in this one. Sometimes you'll be given a balanced or net cell reaction, ionic reaction, and then you are able to answer questions. So in this one, they're saying galvanic cell is set up under standard conditions. Remember, standard conditions we're saying is the concentration of initial concentration of 1 mole per cubic decimeter, temperature of 25 degrees Celsius or 298 kelvins, and pressure of 1 atm or 101.3 kilopascal. So always knows that that table I was showing you is under standard conditions. Now, if you check, when you talk about the salt bridge, the cell notation, we always say A, B for the salt bridge, C. So you can see that this reaction is taking place at the anode. We have the salt bridge, and we have our cathode. Hey, there are so many interesting stuff in terms of our cathode. If you look at that, let me take you through. So you can see that when we start here, we have chromium, which is solid, and then that chromium is separated by a solid line, because we call those lines are phase boundaries. It's showing you that chromium is solid and chromium 3 plus is aqueous solution, and for that reason we got to put a solid line, because it's a phase boundary. I think you understand the meaning of that. And then we have a salt bridge. Remember, we're saying the salt bridge serves us with two functions, which is to complete the circuit and to maintain electrical neutrality through the movement of ion. Remember, the ions are going to move in the salt bridge. The cation to the cathode, the anion to the anode. So definitely that's what we're expecting. Now let me explain here. We're having SN4 plus. Our learners, when they see SN, they don't believe that SN is tin. So this is tin, which is TIN. Please know that is tin. So we have tin 4 plus, which is aqueous, and tin 2 plus, which is aqueous. So you see that the reaction is SN4 plus becoming SN2 plus. So you can see that we have aqueous solutions. Hence, I didn't put a solid line, because these are same phases. We will put a comma there, because the comma is showing that the tin 4+ and the tin 2+ are in different phases. And then when it comes to platinum, where is platinum coming from? Remember, you can't connect your wires to your electrode cannot be an aqueous solution. So always when we have a reaction where we have no solid or a conductor, we will use platinum or graphite. In this case, we are using a metallic. In question 8, most of the time, we are using the metallic conductor, which is platinum. And then you will see that the non-metallic conductor, which is graphite or carbon, we're using mostly in question 9. So you can see that this platinum is our cathode. This chromium here is our anode. So the anode is chromium, the cathode is platinum, because the anode and cathode must always be solids. We cannot have an anode or cathode that is aqueous solution. We don't connect like that our conductors. We need a good conductor, which in this case is platinum. I hope I've clarified that nicely for you, and then you will be able to move. Now, let's move. So you can see that this is what is happening in this cell. Let's go to the questions. Define the term galvanic cell. Galvanic cell. Remember, galvanic cell is a cell. Galvanic cell is a what? It's a cell that converts chemical energy to electrical energy. So chemical energy is converted to electrical energy. And then you are able to get your 2 marks. Now, let's look at the next question, which is write down the standard conditions. Remember, I told you, standard conditions here is not Cape Town. I want to emphasize that so that we move together. It is initial concentration of 1 mole per cubic decimeter. That is what the 1 mark is for. You can't just say concentration. It's initial concentration of 1 mole per cubic decimeter. It's a temperature of 25 degrees Celsius. Remember, when you're dealing with question 6, chemical equilibrium, you just say factors affecting chemical equilibrium is concentration, is pressure, is temperature. But in this case, you are saying initial concentration of 1 mole per cubic decimeter, temperature of 25 degrees Celsius or 298 kelvins, pressure of 1 atm or pressure of 101.3 kilopascal. Please, those are our standard conditions. But remember, pressure affects only gases. So in this case, we're having solids and aqueous solutions only. As long as there are no gases, you can't mention pressure as a condition. So pressure is out in this direction, which means a question that looks for standard conditions is looking for initial concentration, 1 mole per cubic decimeter, temperature, 25 degrees Celsius. So if I don't say initial, will you penalize me? No, we'll give you if we say concentration of 1 mole per cubic decimeter. But because immediately when you say initial concentration, you are acknowledging that immediately when the reaction starts taking place, the concentrations changes. They are no longer 1 mole per cubic decimeter. So it's very much important that the concentration you are talking about is initial concentration. And temperature, we're talking to our temperature in this case of 25 degrees Celsius or 298 kelvins. Now we move right down the formula of the cathode. So already you know that the ABC is telling you that the cathode is on the right hand side of our reaction. So they want the formula of the cathode. This is a trick question. You will think that your cathode is tin because tin is the tin ions are the ones that are undergoing the reaction. But in real sense, your cathode is platinum. Platinum is your cathode because it's our conductor, and our cathode must always be solid. I hope I've overemphasized that, and it will help you as you prepare for your exams. Now, reducing agent. This is very much interesting because now you know that the reducing agents on the table. When I started, I told you about the table 4B. I said when you go down the table 4B, I hope you have the table. When you go down on the left, you have increasing oxidizing ability. So stronger oxidizing agents are at the bottom of that table. And then when you go up, you find your reducing agents. Reducing agents are at the top of the table. So for this type of question, I can go back to the table and check. which one, okay, and check which one is our reducing agent, and definitely it will be chromium, which you'll find at the top of your table, and then your tin is at the bottom, which shows that it's a stronger oxidizing agent, because the reaction is always between stronger reducing agents, which are at the top of the table 4b, and the stronger oxidizing agent at the top left, bottom left of table 4b. So if you have that, you know the reaction is between chromium and SN4 plus. Those are our reactants, and those are the two that are reacting because they are stronger, all of them. The other one is a strong oxidizing agent, the other one is a stronger reducing agent. Now the question is saying, this is a tricky question. I look at it initially and I tried to respond to it faster. You know, sometimes you are too excited to respond and you will find that you are not necessarily responding to the question that is asked. So I look at this question. It's a trick question, and it was my first time to see this one. So I find it very interesting. It said, what is the total concentration of tin ions in the electrolyte? So I looked here. I said, hey, 4 plus 2. Hey, maybe the tin ions are they not 6, but the keyword there is concentration. What is the concentration of the aqueous solutions? We said initial concentration is 1 mole per cubic decimeter. So because we are having 1 mole per cubic decimeter of tin 4 plus and 1 mole per cubic decimeter of tin 2 plus, definitely 1 plus 1, it must give you 2 moles per cubic decimeter. And it was given 2 marks from this paper that we got this question from. So very much important to have understanding of the question. Now write down a balanced equation for the net cell reaction. So even from here, you are able to see it. So you say, okay, we have chromium. Definitely, we are starting with chromium. It's forming chromium 3 plus. It means it has lost 3 electrons. And then we are starting with SN4 plus. Is forming SN2 plus. Definitely, it means it has gained 2 electrons. So you can see already that these are our half reactions that are taking place. At the anode, we are starting with Cr forming Cr3 plus. At the cathode side, we have SN4 plus, tin4 plus forming tin2 plus. And then that's what is happening. And the main thing is that you got to balance the electrons before you do anything. You can't write the balance equation if the electrons are not balanced. So you'll write the reaction that is taking place at the anode and the reaction that is taking place at the cathode. So it means the substance that is at the top right of your table between chromium and SN4 plus, you will find chromium at the top. So it is your anode. Definitely your anode will reverse. So you'll write from Cr going backward. When it comes to SN4 plus, you'll move from that side. It's gaining electrons to form SN4 plus. Then it's like that. Then you have to balance the electrons by multiplying 3 by 2. So remember, if you want 3 and 2 to be equal, you'll multiply 3 by 2, 2 by 3. So definitely you will do that, and you will be able to get your balanced ionic net cell reaction as 3. You multiply this by 3, it's 3SN4 plus, and then you multiply this by 2, you get 2Cr. You multiply this by 2. Remember, when you multiply by 2, you multiply the entire expression. When you multiply by 3, you multiply the entire expression. The electrons are balanced, you cancel them. What is on the left, you write on the left. What is on the right, you write on the right. And remember, that is your 3 marks, which is a percentage in your certificate that you will receive in your statement of results. 1% for writing a balanced equation for the net ionic cell reaction. So it's important that definitely cell notation, you know how to write it. The balanced equation for the net cell reaction, another percent. You definitely have to know it. And then calculate the EMF, more than a percent. More than a percent, this one is 4 marks. EMF, remember, we are saying now, EMF, you have a data sheet, E cathode, EMF of a cell equals to E cathode minus E anode. Copy the equation or the formula as it appears in the data sheet. Don't bring a new one, because you have 1 mark for writing copying the right formula. You have another mark for substitution. You will find that for your cathode, where we have tin, is 0.15, and for your anode, where we have chromium, is negative 0.74. Don't forget to multiply negative and negative, you get positive. Remember, question 8, we said it's a spontaneous reaction, which means the EMF of the cell must be positive. So you got to definitely do that. The anode is the one that you multiplied by the negative, and then you get your answer 4 marks richer. Our last question, as we wrap our lesson, hoping you enjoyed it. Oh, I left this one. How does an increase in the initial concentration of Cr3 plus? Oh, this one is a very interesting question. How does the increase in the concentration of Cr3 plus affect the voltmeter reading? This one you got to see to appreciate that we said our net reaction, cell reaction, we said we had the Cr we multiplied by 2, so we had 2 Cr plus 3 Sn4 plus. We said that is forming Cr 2 Cr3 plus Sn2 plus, which was 3 here. Now, if you look at this, they are simply saying if we increase, remember I talk about a reaction that are reversible reaction. If we increase the product ions, definitely reverse reaction will be, equilibrium will be disturbed, and reverse reaction will be favored. And if reverse reaction will be favored, definitely our EMF will decrease. So always write your equation like that so that you check, are we increasing the reactant ions or the product ions? Remember, if we're increasing the product ions, reverse reaction will be favored. If we increase the reactant ions, the forward reaction will be favored. And definitely we will be able to say when we increase the reactant ions, EMF increases. When you increase the product ions, or when the product ions increases, the EMF start to decrease. So you're able to see that. I hope you enjoy. Our very last question is electrolytic cell, which converts electrical energy to chemical energy. We said this one is non-spontaneous because energy is used. We use a DC power source, and then it's important. Look at that. Define the term electrolysis. Remember, electrolysis is the chemical process. Electrolysis is the chemical process. If you don't mention the process, we are taking that 2 mark away from you, because you got to know that electrolytic cell is a cell. Electrolysis is a process, or it's a chemical process that converts electrical energy to chemical energy. So please, this is important, chemical process. If it says electrolytic cell, you will say it's a cell. We are more strict on that, and I've emphasized it. They're saying now, in this equation, they're saying copper metal of high purity is required to manufacture electrical copper cables. The diagram shows the electrochemical cell used to purify copper. So this is purification of copper. And I always say to the learners, when you are dealing with this one, purification of copper or electroplating, you just look for the metal that you are using. In this case, you are using copper. Just go to your table 4B and look for the equation of copper. You are talking about the one in of 0.34. So it is copper 2 plus 2 electrons forming like that. And at the anode, you just write the reverse reaction of that. At the cathode, you write the forward reaction. So I hope you got that. At the anode, you just write that reaction going backward. And that's what we did. And you get 2 marks just to do that. If the question say write the reaction at the cathode, you'll write the same reaction going forward. I hope I've helped you there. Which electrode is the positive electrode? Remember, positive electrode is the anode. Agree for this question? We are saying don't panic, which means that positive is anode, the bigger one. Positive is anode, negative is cathode. And always we put the impure in the anode, because definitely we want to break it down, this one. We want to remove the impurities and get the pure one to join this one. So this one must definitely increase in mass. This one must definitely decrease, because we're going to lose electron, which means now this is our anode where we have the impure one. This is our cathode where we have the pure one. I hope you have that and it will help you. So impure is on the positive, which is the anode. Now, still the table, very much important here for the question that we're going to do. They are saying the impure copper contains zinc, silver, gold, and nickel as impurities. Identify one impurity that may be oxidized. Definitely, hence we have that table. You are able to check, okay, we're having copper. Remember, we said loss of electrons is oxidation, which is the reducing agent is oxidized. So we're looking for the strongest oxidizing agent, reducing agent in this case. And we're given zinc, we're given zinc, we're given nickel, we're given copper, we're given silver, which is somewhere down there. And then you can see that when it comes to oxidizing agent, it increases when we go up. So the oxidizing agent, it can be nickel or zinc. It can be zinc or nickel, but the strongest one is zinc in this case. That is what the question is looking for. Your strongest reducing agent can be oxidized. So you know that the one that will be oxidized is my strongest reducing agent, which in this case can be zinc or nickel. Explain your answer. I said it, that zinc is a stronger reducing agent than copper. So all of them, zinc and nickel, they are stronger oxidizing reducing agent than copper. Hence, they can be oxidized. State what happens to the impurities that are not oxidized. Remember, the impurities will come and form a sludge here. So they come to the bottom of the beaker there and form a sludge. So they fall to the bottom or they will form a sludge there. And that sludge is made up of those minerals which are very much useful. And then as I conclude the lesson, a current was passed through the solution for a certain period of time. The electrodes were weighed before and after electrolysis. The results are shown in the table below. Look, before electrolysis, mass of impure, this one was 600. After, it was 390. And then the pure one, before, it was 150. After is 320. So you can see that it means how much we have 210. The difference there is 210. What was removed, because we are remaining with 390. And then in terms of how much came here, we had 150. We are now having 320, which is 150. 320 minus 150, your calculator, 170. So you can see that 170 was purified, and then 210 was used. So it means the impurity is the difference there. 170 and 210, the difference is 40. So 40 grams came here to the bottom as part of the sludge. You have your 40, and then 210 is what was purified, what was removed from this one. The one that was pure was 170. So they say use the information to calculate the percentage purity. So you got to say pure divided by impure. But you are talking about the one that was used, the total purified divided by the total removed from the anode there. In this case, it will be your 170 that was used. You divide it by the total, which is 210. You multiply by 100, and then you get your 80.95. So please do this type of questions, which are different questions from the ones that you are always used to, and then you are able to get these ones. And with no wasting of time, what happens to the concentration of the electrolyte during the process? Remember, we said here the copper 2+ is purified. So at the anode, you have the copper plus losing the electrons. At the anode, you have the copper 2+ gaining the electrons. So the electrolyte is not changing here, which means that the concentration of the electrolyte will remain constant. Why? Because the rate of oxidation is equal to the rate of reduction of copper ions. Please always know that for electroplating and for purification of copper, the concentration of the electrolyte remain the same. Whereas for the other two processes, decomposition of copper chloride and electrolysis of concentrated sodium chloride, the concentration of the electrolyte will decrease. So you got to know for this one, purification, the concentration of the electrolyte remains the same. And then even for electroplating, the concentration of the electrolyte remains the same. Why? Because the rate of oxidation is equals to the rate of reduction. With no wasting of time, review of our next lesson, review just in time, revision on the 6th of November 2025, 2:30 to 4 o'clock, we'll be revising paper 1 just before you write your final exam. And then as usual, I would like to say anyone who has never made a mistake has never tried anything new. Those are words of Albert Einstein. And then I would like to thank you very much. Hoping you enjoyed the lesson. You'll continue to revise. Thank you.